Good day, sir. I am the cadet Abarques Christian Joy, and we are Group 1. We're here to report about our given topic, compass, magnetic variation, and deviation. So, our learning outcome, applied compass correction to determine true course and true bearing. So, first topic, marine compass. In China, compasses have been in use since the Han Dynasty, 2nd century BCE and 2nd century CE, when they were referred to as south pointer. However, at first, these magnets were only employed for geomancy, much like feng So eventually, during the Shang Dynasty 1000 CE, many trading ships were then able to sail as far as Saudi Arabia, applying compasses for actual marine navigation. As a result, between 1405 and 1433, Emperor Chu treasured fleet of Dragon Throne ruled the entire South Pacific and the Indian Ocean, a territory that ranged from Korea and Japan to the eastern coast of Africa. At this time, Western mariners were still rather cognizant of the navigational application of the magnet. The first treatise on the magnet itself was written by Petros Peregrinos de Maricourt de Magneti for 1269, and though its nautical use was already mentioned in 1187 by Englishman Alexander Nickham, the use on board only came about the around 13th and 14th century in the Mediterranean Sea. So in 1545, Pedro de Medina Sibela 1493 and 1567 wrote the Spanish standard work Arte de Navegar, only marine compass navigation. This masterpiece was first translated in Dutch 1580 and was irony put into practice by Jacob van Heemskert when the Dutch destroyed the Spanish fleet near Gibraltar in 1607. Jackback obviously was Van Heemskerk's own death during the century. So, magnetic variation. In the Deviation of the 16th century, mariners believed that the magnetic North Pole coincides with the geographic North Pole. Any suggestion otherwise had been denied by Pedro de Medina. Magnetic observation made by explorers in subsequent decades shows, however, that these suggestions were true, but it took until the early 19th century in pinpoint the magnetic North Pole somewhere in Arctic Canada, 78 degrees north and 104 degrees west. From then on, the angle between the true north and the magnetic north could be precisely corrected. For this correction angle is called magnetic variation or magnetic declination. It is believed that the Earth's magnetic field is produced by electrical current and originate in the hot liquid outer core of the rotating Earth. The flow of electric current in this core is continually changing, so the magnetic field produced by those current also change. This means that at the surface of the Earth, both the strength and direction of the magnetic field will vary over the year. This gradually change is called the secular variation of the magnetic field. Therefore, the encountered magnetic variation not only changes with location but also varies over time. So that would be also for my given topic. Thank you.
Now, the correction of magnetic variation. For your location is shown on the nearest nautical chart's compass rose. So in this example, we find a variation of 4 degrees 50 minutes west in 2009. With an indicated annual correction of 0 degrees and 8 minutes east. So hence, in 2011, this variation is estimated to be 3 degrees and 59 minutes, so almost 4 degrees west. And for 2020, the estimated is 2 degrees and 47 minutes west. So this means that if we sail 90 degrees on the chart, the true course of the steering compass would read 94 degrees in 2009 and almost 93 degrees in 2020. So note that the true course is often shown as COG or the course over ground, or CMG or course made good on your GPS plotter. So another example is that let's say that the compass rose in the nautical chart gives a variation of 2 degrees and 50 minutes east in 2019. So with a correction of 0 degrees and 4 minutes east per year in 2021, this variation is estimated to be 2 degrees and 58 minutes. So it is nearly 3 degrees east. So if we sail 90 degrees on the chart, the steering compass or the true course would read 87 degrees. So a paper or digitized nautical chart can feature multiple compass roses. So we use the nearest to obtain the magnetic variation. So here is the example of the compass rose that we found on the nautical chart. So sa tungaan ni sa true north, ang padong north nga arrow na diha ang atong compass correction. So next, the correcting for variation. So the overlaid compass roses on the right illustrates the difference between true north and magnetic north. So when the magnetic variation or the VAR is 10 degrees west, so from the image we find TC is equals to CC plus VAR, in which ang CC it means compass course and TC the true course. So and the VAR it means variation. So to convert a true course into a compass course, we need first assign an number, so to a western and to an eastern variation. So note that this makes sense because of the clockwise motion or the clockwise direction of the compass rose.
Good day, sir. I'm Cadet Condrillion and I'm going to continue the correcting for variation. So here the inner circle is turned 10 degrees anti-clockwise, hence the negative 10 degrees. Now use the same but rewritten the equation. So ato na isot balik. So yung na tong CC compass course equals TC true course minus variation. So 235 degrees equals 225 degrees minus negative 10 degrees. So 235 is the compass course, the 225 is the true course, and the negative 10 degrees is the variation. So to sail a true course of 225 degrees, the helmsman has to steer a compass course of 235 degrees. So to convert a compass course into a true course, we can use the original equation. So di katong ato giri-written. So we have steered a compass course of 200 degrees. So we have to plot a true course of 203 degrees in the chart if the variation is 3 degrees east, or a true course of 190 degrees if the variation is 10 degrees west. So that is the correcting of variation. So next is the magnetic deviation. So what is magnetic deviation? Magnetic deviation is the second commonly correctable error. So we all know ang una kay variation. So second commonly correctable error is magnetic deviation. This time within the ship, which is caused by magnetic forces brought on by pieces of metal such as engine or anchor. Moreover, cockpit plotters and other electrical equipment or wiring if too close the compass. So we all know the magnetic variation from the word magnet. So ang compass na to, we all know ang compass mo magnetic field ba yan ang niya. Mo focus siya sa mga like wiring sa anchor sa engine kay mo kay metal na. So muna naka-cause sa compass error, muna nay magnetic deviation. So the vertical axis states that correction deviation in degrees west or east. So where east is gain positive, and the horizontal axis states the ship's heading or compass course in degrees divided by 10. So thus, in a steering a compass course of 220 degrees, the deviation will be 4 degrees west. So note that on most modern sailing yachts, the deviation will be less than 3 degrees. So when steering compass is newly installed, it often shows larger deviation than this and will require compensation by carefully placing small magnets around the compass. So paano na daw buti nga mga ang compass o mga magnets. So para masakto kay so para simple magkukuan kung dili ba para mabalance. So it is remaining error that is shown in your deviation table. So you should check the table every now and then by placing the yacht in the line of pair leading lights and turning her 360 degrees, a time-honored method known as swinging the compass. Conversely, a handled compass does not have a deviation table. So ang mas nindot daw ang para makaiba ka sa kanya deviation kay gamitan nimo katong swinging the compass nga method para ma-exact. So that is all for my report, sir.
Correcting for both deviation and variation. So, converting a compass course into a true course, we can still use our equation, but we need to add the correction for deviation. Compass course plus variation plus deviation equals true course. So, example number 1. We sail a compass course of 330 degrees with corresponding deviation of positive 3 degrees. See from the table, and from the nautical chart we find that at our location the variation is positive 3 degrees and 330 degrees compass course plus 3 degrees variation plus 3 degrees deviation equals the true course. So giving a true course of 336, which we can plot in the chart. So, and example number 2, we change our compass course to 220 degrees, the deviation is negative 4 degrees, and the variation is still 3 degrees in the chart. And 220 degrees compass course plus 3 degrees variation plus negative 4 degrees deviation equals 219 degrees. That is our true course. And last example, after sailing extensively, our compass course is still 220 degrees. Therefore, the deviation is still negative 4, as you can see it in the table. But since we are at a new location, the nautical chart specifies a variation of negative 10 degrees, 220 degrees compass course plus negative 10 degrees variation plus negative 4 degrees in deviation, giving a true course of 206 degrees. And lastly, converting a true course into a compass course, finding a course to steer or CTS is a little less straightforward, but it's still done with the same equation.
Example 4. The true course drawn in the chart is 305 degrees and the local variation is plus 3 degrees found in the nautical chart, yet we don't know the deviation. So it is question mark degrees, CC plus 3 degrees, var plus question mark degrees, deviation equals 305 degrees TC. Luckily, we can rewrite this. So this reads CC plus deviation equals 305 degrees TC minus plus a negative plus 3 degrees variation equals 302 degrees. In plain English, the difference between the true course and the variation, 305 minus positive 3 equals 302, should also be the summation of the compass course and the deviation. So we can tell our helmsperson to steer 300 degrees. Since with a CC of 300 degrees, we have a deviation of positive 2 degrees as can be deduced from the deviation table. Example 5. The true course from the chart is 150 degrees, and we have western variation of 7 degrees, negative 7 degrees. We will use the rewritten equation to get 150 degrees TC minus negative 7 degrees variation equals CC plus deviation equals 157 degrees. From the deviation table, we find a compass course of 160 degrees with a deviation of negative 3 degrees.
Magnetic course. The magnetic course is the course after magnetic variation has been considered, but without compensation for magnetic deviation. This means that we are dealing with a related equation from above. It talks about the previous quarter, about the examples that they quoted. So this is the equation: DC minus var equals CC plus div equals MC. PC means course, var means variation, CC means compass course, div means deviation, and MC means magnetic course. So in here, how to find the magnetic course. So to go north to magnetic course means variation. So magnetic north to compass course is called deviation. Magnetic courses are used for 3 reasons. First is to convert a true course into compass course like we saw in the last paragraph. So in this equation, true course and compass course are converted to each other. So second is on vessels with more than one steering compass. Also, more equation tables are in use. Hence, only a magnetic or true course is plotted in the chart. So it means that in all vessels, the more the steering compass, the more the deviation tables are used. But only magnetic course or true course can be plotted in the chart. So last is the bearings taken with a handheld compass often don't require operation for a deviation and are therefore useful to plot in the chart as magnetic course. So a handheld compass, it won't require operation for deviation. It is also useful in plotting the chart as a magnetic course. So note that the actual course are lines the navigator draws or plots. In the chart or plots in the chart are always true course unless C means course. To summarize, we have 3 types of north, means true. The first north is true north, second magnetic north, and last is the compass north. All these are related by deviation and variation. Glossary. Variation means the angle between the magnetic North Pole and the geographic North Pole, also called the magnetic declination. Secular variation, the change of magnetic declination time with respect to both the strength and direction of the Earth's magnetic field. So to understand more the secular variation, visit this highlighted link. Next is west and east. West variation or declination, or east variation or declination, as well as west or east deviations are designed with a negative sign by a convention due to the compass card's clockwise direction. So deviation, the compass arrow goes by electrical cards and or metal objects. Deviation table means a table containing deviation in degrees versus the ship's heading or the compass course in degrees, usually plotted in graph or card. True course means the course corrected for past errors and plotted in the chart. TC or TCN is equal to course over ground or COG, or also course made good or CMG. Compass course or CC or CDS, the course which is corrected for both variation and deviation. Magnetic course or MC, the course which is only corrected for variation. This equation CC plus bar plus dev equals TC. This equation shows that the connection between compass and course, its errors and true course can also be read as TC bar minus bar equals CC plus dev. So that's all, sir, for group 1.